In this problem, a beam of light is traveling from air into a piece of glass. We're given the index of refraction for that piece of glass. We're given the angle of incidence. What is the angle of refraction? So if we can picture, we have air and we have that boundary between the air and the glass. Well, air has an index of refraction of 1. This glass, it's told to us, is 1.51. We have our imaginary normal line here that's perpendicular to the surface. And so we have this light ray coming in here at an angle of 61 degrees. Well, as that light travels into the glass, it's going to become slower, and this angle must become smaller. So instead of coming on straight here, we're going to have a smaller angle. And that's what we want to solve for. What is this angle of refraction? This means we want to use Snell's law, that the first index times the sine of the first angle equals the second index times the sine of the second angle. We want to solve for angle number 2. So I'm going to divide by n2, and then as the sine comes over, it becomes the inverse sine of all of this fraction. So the inverse sine of the first index 1 times the sine of 61 degrees divided by the second index 1.51. I'm going to do this fraction first, and so the 1 there we don't need. Sine of 61 divided by 1.51, and I'm going to do the inverse sine of that answer. And we get a smaller angle, 35.4 degrees.